Hello, thank you, good student, and welcome so that we can go through this particular question. The question that is given at this particular point is a question that is coming from the angle properties of a circle. So the question goes that in the figure below, PQR and S are point on the circle center O, PRT and also USTV are straight lines. Line UV is a tangent to the circle at point S. Angle RST 50 degrees and also angle RTV is 150. So you're told to calculate the size of angle QRS, angle USP, and also angle PQR. Now B, you're told that given that RT is 7 centimeters and also ST is 9 centimeters, you're told to calculate with three significant figures the length of line PR and also the radius of the circle. So looking at that particular circle, we can actually use what we call the properties of angles in a circle and try to fill these particular angles as follows. So what I'm going to do here, we are going to first of all to use that angle properties in a circle, also angle properties in a triangle, so that we can fill this particular area. So first of all, this angle is going to be 30 degrees. Why 30? Angles in a straight line add up to 180. Now this angle is going to be 100 degrees. And I'm wondering why 100 degrees? 100 degrees because angles in a triangle add up to 180. So 30 plus 50 from 180, you remain with 100 degrees. Now the whole of this angle down here, the whole of this angle, this one up to there, this angle is going to be 80. It's going to be 80 degrees. Reason for 80 degrees again is that angle in a straight line add up to 180. Now this angle, the one I've gotten as 80, alternate with this particular angle down here. So this particular angle is also 80 degrees. Reason for that particular aspect is that angles in alternating segments are equal. Similarly, this angle, which is 50 degrees, is also alternating with this angle, which is also going to be 50 degrees. Now, once you know that this is 50 degrees, then we should also know that angle at the center of a circle are twice that of the circumference. So this particular angle is going to be 100. So because this angle is twice this, and if this is 50, then this is 100 degrees. Once we know that, we can again know that angles, the radius, remember this is the radius, and also this is the radius. The radius and the tangent make 90 degrees. So if this is 80, the smaller angle remaining here is actually 10 degrees, so that it can make 90. Angle between a radius and a tangent are right angle. Once we know that, then we can talk of a four-sided figure inside a circle whose vertices touches the circle is a cyclic. So you can see P, Q, R, and S is a cyclic. Therefore, opposite angle of a cyclic add up to 180. Therefore, if this is a radius and this is a radius, then this particular angle is 40 degrees. This angle down here is 40 degrees. Why is it 40 degrees? Because it is base angle of isosceles, a triangle. So if this is 40, then the whole angle, this angle up to here, the whole of this angle will be 10 plus 40, which is 50. And therefore this angle will be 130. Remember, angles, opposite angle in a cyclic add up to 180. Once you have them, then you can go to the questions. The first question was asking for the angle ORS. That is ORS. We've already gotten that angle as 40 degrees. And how did you get it? We say that base angle of isosceles triangles are equal. We also calculated another angle by USP. The angle USP. Look at it. USP. That angle is 80 degrees, and we have actually used the property that angles in alternating segments are equal. Then we also got another angle PQR, and this angle PQR is actually 130. How do you get 130? Angles in alternating segments add up to 180. So if I got this one as 50 degrees, then this is 130. Opposite angles of a cyclic quadrilateral add up to 180. And that's how simple those three angles were to be calculated. Now we will proceed on to the second question. And the second question was actually inquiring of that given that RT is 7 centimeters, ST 9 centimeters, you're supposed to calculate with three significant figures the length of the PR. So I've actually extracted this triangle together with the circle, and you can actually see that PRT is a secant and ST is a tangent. Once we know that, then we recall that a tangent and a secant are related by this particular relation, where we say it is PT times RT equals to ST squared. Then we proceed on to substitute that particular value. Remember, this is 7, and then PT is 7 plus X multiplied by 7 equals to 9 squared. Then if we expand it, we are getting that it is 7x plus 49 equals to 81. Then we are getting 7x is equals to 32. And dividing both by 7, we are getting that x equals to 4.57 centimeters. Remember, that is to three significant figures. Once we have gotten that, then we can proceed on to question B Roman 2. And in the question B Roman 2, they were asking for us to find the radius of the circle to three significant figures. Under this, recall that this particular one, we can use what we call the sine rule. I've extracted that triangle from that particular figure. Remember, we had PS and R, and this angle already from the figure, we got it as 50. PR, we have calculated it and we got it as 4.57 to three significant figures. So what we do, we then apply the sine rule. We apply the sine rule. Remember, the sine rule with the radius is sine S. We know this angle S and also side S. So it will be sine S over sine S equals to 2R. This is part of the sine rule. Once we know this, then we can substitute. Remember, S is 4.57, and then sine of that angle, which is 50 degrees, is equals to 2R. Then what do? We simplify. Simplifying and making R the subject, then we get R is equals to a half times 4.57 over sine 50 degrees. And if you put this one into your calculator and work it out and simplify, then you're going to get the correct answer being 2.98 centimeters, again, to three significant figures. Remember, this question was also set and appeared in the KCSE of 2016, paper 2, question number 18. So I appreciate for your time, and also I believe that short demonstration as an example has actually boosted your understanding of that particular area of angle properties of a circle. Remember to be part of my class by subscribing so that you can be notified whenever a new video is uploaded. Thank you, and also be blessed.